Good morning and welcome to our third Engineer to Perform webinar. My name is Deborah Golden and I am the Inside Sales Representative at Swagelok, Michigan, Toledo, and I will be your host today. Today's discussion is on hoses and how to extend the life of your critical operations. Our guests today are Doug Nordstrom and Nick Iverson. Doug has spent the past 5 years in product manager group and is currently the Senior Product Manager for the Hose Group. Nick started his career with Swagelok in 2012 as a product engineer and application specialist, and Nick is now our Central Area Field Engineer. Now, before we start, I have a few housekeeping notes. As it pertains to our dashboard, you will notice that there are several widgets at the bottom of your screen. The first is a speaker bio page where you can learn more about today's guest. Also, there is a slide widget, and you will notice the On24 screen is not like other webinars. You have the ability to move the boxes on the screen by clicking and dragging them to any areas that you're comfortable with. Next, there is a survey link, and I will tell you more about that today when we get to our break. We also have a widget for Q&A, and as you listen to the presentation, think about what your hose questions are, and you can type them in at any time. After that, you'll see a resource link, and here you'll find an extensive library of hose information that may be of value to you. And finally, there are links to our LinkedIn page and contact page. So today's webinar is also very interactive. We want you to ask questions and respond to polls. Now I'll turn it over to Doug and Nick. Gentlemen, welcome, and thanks so much for being with us today. We are looking forward to you helping us understand more about hoses and how to extend the life of our hoses.
Yes, thank you, Deborah. This is Doug Nordstrom, and I want to thank everyone for joining our webinar on selecting the right hose. And as Deborah said, please feel free to ask any questions at any time, and we will make sure that we get as much answered as we can during our 1 hour. So with that, our agenda for today is, first of all, it starts pretty simple. What is a hose? And then we will go into what the acronym STAMPED means and how it's important in selecting the right hose. And then we have 3 what we call advanced topics we'll get into that pertain to selecting the right hose and making sure the hose will last as long as possible for an application. And those are permeation, understanding what impulse and dynamic bend do to a hose life, and also understanding what a braid package is. And then Nick will discuss common issues that he has seen in the field and how to avoid them with different hose applications. So first, we'll start easy. What is a hose and what is a tube? So to understand the impacts of different things on a hose, we start with what is a tube. Tubing is a single-layered conduit which fluid flows, gas or liquid flows through. And we all think of tubing as, either stainless steel seamless or stainless steel welded seamed tubing that's rigid, and you can heat trace and insulate and do different things to these tubes that improve the performance of a tubing in a fluid system. But it also could be flexible tubing. Now, these are single-layered tubes, right, that are still flexible. So people think of this as a hose, but technically these are actual tubes, and that we make them flexible, but they still act like tubing because they have only one layer. So a hose, what is a hose? A hose is a multi-layer conduit where gas or liquid flow through. And these multi-layers are what make hose much more complicated, but also allow for the hose to perform better than tubing in some applications. And the different layers are listed here. They consist of a core tube, which is the wetted surface of the hose. It sees the media, and so it's important to understand how the core tube is going to interact with the media. There's the braid, which the braid is the pressure-containing layer or component within the hose. It's what maintains the pressure, and so the stronger the braid, the higher the pressure the hose can contain. The cover, which could or could not exist on a hose. Sometimes some hoses don't have covers and the braid is exposed, but some hoses have a cover that makes it cleanable or more abrasion resistant. And then there's the end connection, which obviously is used to connect to the system. And the end connection is inserted into the hose and either crimped or welded or just pushed in, and it needs to maintain the same pressure rating as the rest of the hose. So as Swagelok has been in the hose business, we've gone around and inspected, visited customers, and we collect data, and we collect some comments that different customers have made. And some of them are listed here, and it gives the impression or tells us how different customers think of their hoses in their plant. So some people say a hose is a hose is a hose. Just use whatever hose is available on the shelf. It doesn't really matter. Why does it matter which hose I use? I just need to get it connected so the system is up and running again. And the hose lasts a couple months, but it's the way it's always been, so it's just what should be expected. But then other customers look at things a little bit differently, and they understand that selecting the right hose can greatly improve the way the system works. It can also greatly improve the overall safety of a plant, which can be even more important, of course. Some comments here. Vibration used to cause leaking within weeks with our hose, but now we've selected the right hose basically and have no issues. Simply changing the way the hose was routed has completely changed our maintenance program, so the customer is able to change the preventative maintenance schedule based on the routing simply. All we did was change the hose series, and it lasts now over 20 times longer. Again, so the same system parameters, pressures, temperatures, and what have you, but now the hose lasts 20 times longer because the right hose is selected. And basically, we won't think of a hose as a commodity again. So, you see different efficiencies based on whether or not a customer is really engineering the right hose into the system, or if they're just using whatever is available and off the shelf or whatever was used last time. It can greatly impact how a fluid system works and how a overall plant is operated. So we want to ask a question to the group, and this can depend on what kind of media you have at your facility, but we sell, and on the market there's many different types of hose. There's metal core, there's Teflon or plastic core, thermoplastic, and rubber core. And so we're interested in learning a little more about what kind of hoses you use. So at this point, we'd like to take a quick poll on what type of hoses you commonly use in your facility. It could be you could use all of these, but what do you use the most? Okay, so it looks like we have no thermoplastic users out there, and this actually is in line with what I kind of expected. We see when we go around to customer sites a lot of Teflon core and metal core. We do see a lot of thermoplastic, but Teflon and metal core tend to be the highest used hoses that we see as well, so good to see that this is in line. Now, one more survey question before we move on to what stamped is. You probably can tell from the question here, but what factors do you use when selecting a hose? So it could be the size range, the temperature of the application, what kind of application it's going into, what the media is, whether or not it's corrosive or gas or liquid, what the pressures are, end connections, delivery considerations, or maybe none. Different customers look at these different factors for different applications in many different ways. Okay, so most people say the application. That's good to know. What we I think you probably can tell where this is going. We recommend that all these are looked at very strongly, and we'll get into why. Yeah, so no one says media. Very interesting. Okay, so again, we recommend the entire stamped acronym to be looked at very closely when selecting the right hose, and we're going to explain a little bit why and go into some detail on a couple of these in a little bit later. But the first one of stamped is size, and what that basically means is, are you going to get enough flow through the application, and is the hose the right length for the application? And that second bit is something that is forgotten quite a bit. So the size, is the bigger the hose, the larger the flow you can get. And a general rule of thumb is if you double the diameter, you quadruple the flow rate, because of course when you square the radius is the flow area. So the radius is a squared term. So you quadruple the flow rate. So you go from quarter-inch hose with 50 psi water can flow 20 liters a minute, and a half-inch hose can flow 80 liters a minute, and so on. So you need to make sure you get enough flow for whatever your media is. And there's various calculations to determine that, but many times that's already known going into the application. More importantly, though, with hoses, many times they go into a dynamic application. So the hose is moving and bending, and it could be doing that repeatedly all day long, or it could be just on occasion. But different movements require different amount of excess hose to complete the movement without damaging the hose. And that can be forgotten when selecting the right length of hose. We see it many times customers look at a hose length and say it has to go from point A to point B, and those 2 points are 10 feet apart, so I need a 10-foot hose. Well, point B might be moving up and down, and to complete that movement without kinking or overbending the hose, you might need a few extra feet. And there's various calculations that need to be done to make sure that the hose is the right length. And those can be found in various industry handbooks, and our Swage Lock, of course, representatives all know how to do those calculations as well. Swage Lock field engineers, and again, they're listed in many different places. But they do need to be done correctly, or the hose will not last very long at all. It'll overbend and fail very quickly, especially in a repeated dynamic application. Next in the acronym is temperature, T. So this is pretty straightforward. You need to make sure that the hose obviously meets the temperature requirements of the application. And this typically comes down to what the core tube is made out of. This core tube usually is the temperature restrainer. Not always, but most of the time it's the temperature restraint in the hose. And you can see the different core tube material options here. Polyethylene, only rated to 150 F usually. It can vary a little bit from this, but you can see it's a pretty tight range, -10 to 150. Nylon and rubber, or the rubbers being like Viton and Buna and other different rubber materials. Typically a little bit broader of a temperature range, -40 to 200 or so, depending on the material. Fluorocarbons, basically the Teflons and PTFEs, PFAs, cores, widen that range quite a bit, especially on the upper side, up to 400 or 450, or depending again on the material and how the Teflon is formed, but it gives a wider range. And then of course the widest range being the metal core tubes are offered up to 1,000 or so, depending again on how it's made and what the material is, and as low as -300 or so. So again, if temperature is a concern, it will affect what type of core tube is required out of the hose. Next in the stamped acronym is application. Now this was people's top choice, and I understand you could only choose one out of that list, but this was people's top choice. And there's a lot of things we can talk about with application. Many times this can come into whether or not there's vibration in the application, whether or not there's a lot of movement, whether or not it needs to be connected and disconnected many times. But in this particular case, what we're going to focus on are the pressure variations. And so this isn't necessarily the overall system pressure, but basically how much pressure variation and how fast does it happen in a system. And we break this down when we consider hoses into 3 groups. The first being pressure impulse. So in other words, there's a pressure increase or decrease very, very quickly. And so we see this as a large pressure variation in under 2 seconds. And so this can happen from most commonly opening and closing a ball valve. And so you can imagine a quarter-turn valve that opens well under 2 seconds, almost instantaneously. That full pressure flows into or out of the hose very, very quickly, and we call this a pressure impulse. Now this is different for gases and liquids. Liquids being incompressible are the worst case because the momentum of the liquid actually does damage to all the components in a fluid system with a pressure impulse, including hoses. And so the core tube needs to absorb all that momentum when a pressure impulse occurs. And different core tubes are better at absorbing that impulse. This is very similar also in your house. You have water hammer when you open and close a sink, for example. You can have water hammer in your house, and that's just with a few psi, really, not thousands of psi that you can see in some of our fluid systems. So this can be something that can really affect a lot of components in a system. The next one, like a pressure surge, we call it. That's a slower increase and decrease, but still on the fast side. So this could be opening and closing a multi-turn valve, like a needle valve or a gate valve, can cause this type of pressure surge. It's still, obviously, the components need to absorb that momentum, but they can do it over a longer period of time, so it's less impactful on the life of the components in a system, including the hose, but it does still have an impact. And then pressure cycles are things that happen over 10 seconds, sometimes over an hour or so, and there could be variations in the application and the process or whatever is going on in the plant that cause a pressure cycle, and they tend to not have a major impact at all on systems because the components are able to absorb that over a long period of time. So we really want to look at what a pressure impulse is and how it can impact different hoses. And we'll get into this a little bit more with one of our advanced topics. Next is media. And by this, what I mean is, what is the media? Is it compatible with all the wetted components in the hose? And also, is it a gas or liquid? And how does that impact the way the hose is going to perform? So on the right side of the slide here, you see, incompatible medias with different hose components. And the top one being essentially the media is dissolving the hose material. So it's a solvent. And so the wrong hose material was selected for the media that's going through that hose. And the bottom one there is it's a corrosive media, and it's attacking the actual metal of the end connection. And this can also happen with attacking the metal of an all-metal hose. On the bottom left, though, this is the topic we'll get into a little bit more in some detail with our advanced topics, is permeation. And what permeation is gas molecules flowing through the actual material. So there isn't a leak path, but they actually flow through the material and out of the hose. And this can happen with hose core tubes. It can happen with valve seats. It can happen with anything. Permeation happens with in many different places in a plant, and it has to do with just how tightly the material is made. And the way we like to describe it, that I think is a good visual, it's different materials are like a plate of spaghetti. And so if you look down on the top of a plate of spaghetti, you can't see through to the plate. But if you pour tomato sauce on top of the spaghetti, eventually the tomato sauce will flow through the spaghetti and get to the plate. That's similar to what happens with permeation in a Teflon or a fluorocarbon or a rubber. So eventually the gas molecules will flow through the material and get through the other side, essentially like the sauce getting through the spaghetti to the plate. And so we need to understand what that permeation is so we can select the right hose for whatever gas is flowing through there. Okay, I think I have a question here. We have a question. Would a convoluted, I don't know how to read the full question. Okay, here we go. Would a convoluted metal hose fatigue quicker under pressure spike or surge situations? That's a very good question. So if I could go back one slide here, a convoluted metal hose is going to fail faster with the pressure impulse. By the definitions we have here on this screen, a pressure spike and impulse are essentially the same thing. So that pressure impulse will be the worst case for a metal hose. Now, back to the core tube types, we have all metal, and there's fluorocarbon and rubber and thermoplastic. The all metal will perform the worst with impulse because it has less ability to absorb the momentum, either starting or stopping of the liquid impulse. So the all metal will perform poorly under impulse, and the fluorocarbons and the nylons will perform better under impulse. And I have a slide on that again in a little bit. Next in our stamped acronym is pressure. Now, we talked a little bit, again, about the pressure impulses and things, but what we're getting at here is just what is the system pressure? What is the design pressure, ignoring the impulses and spikes and surges and things? So the things to look for here are listed. The first is vacuum. Is the hose rated for vacuum? Some hoses are not. And in these cases, you get vacuum collapse. And that's what this top picture is. The actual core tube collapses and chokes off flow because the vacuum sucks the core tube in onto itself. So it's important in a vacuum application, of course, to make sure the hose is rated for vacuum. And there's times customers actually do not know if there is vacuum in their application, and vacuums can happen without an actual vacuum pump. You can have Venturi effects and things that cause vacuums in a system. So it's important to understand if that's going to occur if you're selecting a hose that's not rated for vacuum. Many are, but not all of them. And then, of course, as a safety concern, if you overpressurize a hose, you can have rupture. In this case, that picture is not quite ruptured yet, but it sure looks like it's close. And that can be a safety issue that needs to be looked at. Now, most hoses, and all of Swagelok hoses, are rated to a 4-to-1 burst rating, which is always good to know, of course, what the burst rating is on any hose, because if in upset conditions in an application, if you see that type of situation and a hose bursts, it's a big safety issue. Another important thing to note with pressure is how a hose will fail under the burst situation. Hoses that have an end connection failure could be a significant safety concern in a plant, because now you have full flow leakage essentially from your end connection failing. The best hoses are designed so that the actual hose length bursts, not the end connection fails, and that's an important thing to note when selecting a hose, is especially in a higher pressure application, is how will the hose fail under overpressurization? Will the end connection fall or rupture off, or will the hose length itself burst, which is a much safer burst method? Next is end connection, and of course this is fairly straightforward, but the end connections usually are chosen that fit into the system, so whatever we're connecting the hose to. But the thing we can run into with this, and all end connections really are offered on hoses, but what customers run into is a hose that needs to bend a certain way in order to be installed. So if it's, for example, a threaded system, and one end of the hose needs to thread in and the other end of the hose needs to thread in, you can run into issues where the hose just doesn't do that in order to be able to be installed. So you need to have full movement of the hose as it's being installed, and so rotatable tube adapter ends, sometimes are used, or swivel ends, as you see in the bottom left, can be used so that the hose can not rotate as the end connection is being threaded into a system. And then lastly is our delivery considerations, and this one is probably the easiest of all. But this could pertain to a lot of other things related to the hose, such as is special testing needed in order to ensure that the hose is made properly. There's a lot of different testing that can be offered beyond the standard production testing. And are there things like special tags, special labeling, special ley lines that might be needed in order to have the hose marked properly for the application it's going into? And then how should the hose be shipped? Is it okay to coil, or does it need to be bagged, and things like that, so that the hose arrives in the proper cleanliness and proper condition. So again, pretty straightforward. So at this point, are there any questions on? Yep, go ahead.
Yeah, I was going to say, wow, there's so many things to be considered. I did want to remind our audience before we move on to our advanced hose section to please make sure you're completing the survey that can be found under the survey tab, so that we can make sure we're addressing your specific needs, even if it's after the presentation. So thank you. Go ahead, Doug.
I was going to take a quick break here just to see if there's any questions. Suppose I can do this pulse check. How are we doing with the topic so far? Any questions out there on the stamped acronym? Looks like so far so good. Okay, great. Everyone seems with me so far. So now we're going to get into some more advanced topics, and we touched on them a little bit with the stamped acronym, but we want to explain them in a little more detail because this is where people really go wrong when selecting hoses sometimes, and so we want to make sure that they're understood as best as we can. So the first one being permeation. Now, when we think of a component leaking, we usually think about what's shown here on the screen, where either there's a crack in some material and fluid media, liquid or gas, can flow through the crack and escape, or it could be something where there's not enough sealing force, and so the actual material, the seal, is not making a seal on the component it's supposed to be pressing against, and again, fluid media is escaping. Obviously, these are bad. We don't want leaks, but it's not what permeation is. What permeation is gas molecules usually, although liquid can permeate, but not nearly to the rate gas does, so it's usually a gas concern. But gas molecules enter the media, like that plate of spaghetti, and they flow through the media to the other side, to flow through the, whether it's a hose wall or a valve seat or whatever it might be. And the gas molecules escape to the other side. And it's more of a function to do with what the gas is and what the media, or what the component seal material is. Okay, we have a couple questions here. I'll go into those. First one is, does fiberglass braid resist permeation? We've actually done some testing on this, so it's interesting. What we found is that the braiding itself on a hose resists no permeation whatsoever. We thought maybe it might, but this is happening on such a small molecular level that the holes between the braid actually do absolutely nothing to resist permeation. The only thing resisting permeation in a hose is the core tube. So whatever that core tube permeation rate is, the hose will see. And it will permeate through, the gas will flow through the braids basically instantly. Okay? A good question. We've actually thought about that and went into testing it. So again, permeation flows through the core tube or through a valve seat or through a fitting connection, whatever it might be. And it happens at different rates based on the gas and based on the material it's flowing through. And it has a lot of other variables as well. And this is why permeation is a difficult topic to properly address in a lot of detail or a lot of precision. But the more pressure inside a hose, the more gas molecules will enter the hose and permeate through. The higher the temperature, the actual Teflon or hose core material will expand, making the holes larger, so increasing permeation, basically separating the spaghetti more, right? Actually, flow rate does not affect permeation at all. We thought maybe it might, but flow rate through a hose does not affect permeation at all. The smaller the gas molecules, as shown here, like helium and hydrogen, will permeate much faster than larger gas molecules. And actual gas permeates obviously much faster than liquid. Liquid almost permeates to a level that is zero. The thicker the wall, or for example, the thicker a valve seat or whatever it might be, the slower the permeation will be. It's directly proportional. So if you double the wall thickness of a hose, you will half the permeation rate. And the materials of construction, there's different things you can do to rubbers and plastics and Teflons that will slow permeation, but it has other effects. And so we want to get into some of those effects. And to understand the effects, we want to make sure that we understand these two core tube types. So the first we're going to compare is a fluoropolymer core tube. So this is a Teflon, PTFE, PFA, other different material core tubes. And there's things we can do to these core tubes that change the permeation rate. But in general, they're permeable. And you can get these core tubes with carbon black that help with something called static dissipation, which we don't have time to get into today. But they're smooth bore, so they're cleanable. And they tend to be more flexible. That's their advantage. The disadvantage tends to be that they're permeable. And so just virgin Teflon tends to have relatively high permeation rates. And we can take this Teflon and bake it, and we call that a sintering process. And we can bake it at different lengths for different amounts of time. And what that sintering process does is tightens up the molecular structure of the Teflon. It makes the spaghetti closer together, and so it also then slows down the permeation rate. And there's two that we use at Swagelok that we call slow sintering and post sintering. Slow sintering being a slow baking process after the core tube is made, and a post sintering process is a very long bake after the core tube is made. Slow sintering, think of it as a pizza oven, where the core tube slowly moves through an oven, like a pizza. The post-sintering is taking the entire core tube and putting it in an oven and leaving it there. You're baking a cake, basically. And it stays there for a long time, really tightening up the molecular structure of a Teflon. The other core tube type is a metal. And you can see from this picture, the metal core tube is a convoluted core. And so the advantage of it is it essentially has no permeation. Now, metal does permeate, but it's on such a low level that it really doesn't matter. And as we talked, it has a very high temperature range, but it has no permeation. The disadvantage tends to be it's a little bit less flexible, and it has entrapment areas. You can see it's not a smooth bore, so it's not quite as cleanable. You can have liquids and things being trapped in those convolutions. So when we talk about permeation, permeation is interesting because gases permeate in the direction where their partial pressure is lower. So it's a little bit non-intuitive. But if we look at this example here where we have air on the outside, and air consists of about 12 psi nitrogen and about 3 psi oxygen, give or take. And on the inside of this particular hose, there's 1,000 psi nitrogen. So the pressure differential in nitrogen is 988 psi on the inside. So nitrogen will permeate out of the hose at a rate of equivalent to 988 psi differential. That tends to make sense. What people don't always understand is that there's 0 psi oxygen on the inside of this hose, and there's 3 psi oxygen on the outside. People tend to assume that 1,000 psi of nitrogen will stop the oxygen from permeating in, and that's absolutely incorrect. Oxygen will permeate into this hose at a slow rate because it's only 3 psi, but it will permeate into this hose. So that's something that not everyone really is aware of, and it can affect the way hoses work if it's important to keep oxygen out of a system. In this case, it will not. It will permeate into the hose. So it's important to understand the partial pressures of every gas that's surrounding a hose if permeation is a concern. And what permeation tends to look like in a hose, this is a hose submersed in water, and this is just virgin Teflon, so there was no sintering process on this particular hose, so it's permeating at a bit of a higher rate. And all along the length of the hose, it appears to be leaking because you get these bubbles on the outside of the braid. And technically, I suppose it is leaking because permeation could be considered a leak, but there is no crack in the hose. There's no failure point. It's just permeating whatever, I think this was nitrogen, out of the hose, and the gas bubbles are collecting on the outside. So when we look at relative permeation rates, Swagelok has done quite a bit of testing with this, and we're actually going to start doing much more. But we look at relative permeation rates of different core tube types, and we have some listed here. So mechanically and hydroformed metal core tubes, we'll talk about what that means in a minute. And then we talked about these three Teflons. So there's normal Teflon, there's the slow sintered, which is like the pizza oven Teflon, and then there's the post sintered, which is baking a cake Teflon. And then there's different rubbers, right? Buna, Viton, Calrez, whatever it might be. And if you look at relative permeation rate, if you say metal is a 1, so very, very low permeation rate, a post-sintered Teflon permeates about 10,000 times more than that. A slow-sintered Teflon about 20,000 times more. So a slow-sintered permeates about twice as much as a post-sintered. Normal Teflon, though, permeates about 10 times a post-sintered Teflon. So that post-sintering process that is done cuts the permeation rate of a Teflon into 1/10. And so that's the advantage there. And that slow sinter process, you can see, cuts it in 1/5. And then rubber hoses will permeate the fastest because the material structure has the largest holes between the molecules of the hose. Okay, we have a question here. What hose is recommended for a high-pressure CNG up to 3,600 PSI? Typically for those type of applications, we recommend our thermoplastic product lines, which we don't get into those applications in this presentation, but I'd be happy to send some detail on that later. But that's our thermoplastic nylon core, essentially, products. And we have another question now, too. How long should the hose be when used to absorb vibration? Yeah, that's a very good question. Is Teflon or metal a better choice? And what about routing the hose? Those are very tricky questions. The easiest one is that middle one. Teflon is better for vibration. Metal, like a metal paper clip, will, if you bend a metal paper clip continuously, eventually it will break. Teflon will last longer. So for pure vibration, we recommend Teflon. As far as routing the hose, I think what we would need to do is have a field engineer, and Nick could talk to this later, actually look at the application, or you can send us a video and we could make some recommendations. That can be tricky. So we'd have to see what kind of equipment is around where the hose is installed and see if there's things we can do to help work on that. So and that really gets into the art form of routing a hose, which is a tricky topic. Okay. Any questions on permeation? I'll do another pulse check. So again, in general, when selecting a hose that's going into a situation where permeation is a concern, all metal is by far the best. But if you need to use a Teflon because of things like vibration, like was just mentioned, or cleanability because of the smooth bore, make sure the Teflon core has been sintered to some fashion, and post-sintered again is the best. Okay, looks like people are still with me. We're going to move on now to impulse, and we discussed what these different impulses are: impulse, surge, and pressure cycles, so I won't repeat that. But this comes into play with metal core tubes because, again, metal absorbs impulses worse than Teflon core. And so a metal core tube can be made two different ways. But before we get into that, what basically is done is a steel strip is turned round and then seam welded down the length of the round tube. And then we form these convolutions in that tube. And those convolutions can be formed two different ways. They can be formed mechanically, which essentially is a press form that pushes the material into the convolutions, or they can be formed hydroformed. And a hydroform is pressurizing the inside of that tube with water and making it create that form against a die. And that's a far superior way to form a metal tube because it spreads out the forces evenly along the entire core tube. And this keeps the core tube thickness the same, so we can maintain a 4-to-1 burst. There's no thin spots. And it also spreads out the residual stress so that there's no high stress or low stress areas. And mechanically formed, you get high stress areas right where the forms are made, and it also makes very thin sections of the core tube, which can affect the burst rating. Now, we see this come into play when we look at how a core tube, metal core tube, withstands impulses. So we look at this same graph we looked at for permeation. When we look at these same core tubes and how well they can withstand impulses. So we impulse cycle these core tubes and test and see how long they last, essentially how many impulses they withstood before rupture. And a mechanically formed metal core tube will last in the neighborhood of 10,000 impulses. So when we do that ball valve cycle test, we look and see how long the core tube will last. It's only 10,000 as compared to a rubber, which lasts well over 1 million. The hydroforming process that is done spreads those stresses out, maintains the correct wall thickness in the core tube, and we get about 7 to 8 times the number of impulses out of a hydroformed core tube. So again, it's not quite to the level of Teflon still. Teflon being a softer material can absorb the pressure impulse much better, and we get hundreds of thousands based on the Teflon. But hydroforming metal does increase the impulse life a great deal. Now you can also see the sintering process decreases the actual impulse life because what is happening during the sintering process is you're hardening the material. You're compacting it and hardening the Teflon, so it improves the permeation, but it decreases the impulse life. It's still very high, but it decreases the life a bit. So these things are, again, important to understand with your application to see what type of core tube is right. Okay, so the question here, I got another question. Does the PTFE core tubes and the swage lock hoses, do they undergo a post-sintering process? Yeah, again, good question. We offer our T-Series hose is a post-sintered Teflon. So that is, again, baking the cake. It's the long process. So it is the best permeation out of any Teflon, but it slightly decreases the impulse life. Our other PTFE core tubes, such as the X series, is a slow-sintered Teflon. So it is in the middle there. We offer no virgin Teflon core tubes. We only offer slow-sintered, which are the X and the S and the W and those things, or we offer post-sintered, which is our T. Okay, I'm going to do another pulse check on hydroforming process or impulse life to make sure we're still on board, and then we'll go to our last advanced topic of the day. Okay, looks like people are still good. It's great. The last one here is understanding what a braid package is. And the braid, now we're getting away from the core tube, which is what we talked about with permeation and impulse life. We're going to talk about the braid package. Now the braid, again, is what gives the hose its strength. It's what gives it its pressure rating. And it also gives the hose some strength to kink resistance. Braids are typically metal, although they can also be fiber, Kevlar, different things that change the performance of a hose. And what a braid package is the angle of the braid, along with the number of braids in the hose and the wire material, the wire thickness. All that needs to be specified by proper braid package. And one thing that we have found be very, very important is the braid angle. So that's part of the braid package. Of course, we specify the number of braids, the wire thickness, the wire strength, the wire material, but then we also specify what the braid angle is. And we found this to be a very key component in how a hose works. Even though all hoses may look the same, based on the braid angle, they can perform very, very different. So what the braid angle is the angle, of course, that the braids wrap around the outside of the core tube, as you see with the red lines. And if the braid angle is too shallow, so these wrap around the hose, I guess, too quickly, what happens is, under pressure, they steepen, and the hose core tube is allowed to grow in diameter. And the hose also, because the material just can't be made magically, the hose, when it grows in diameter, the hose actually shrinks in length. And this can lead to some pretty catastrophic failures. First of all, the core could burst because the core just can't withstand that kind of growth in the diameter, and the core can burst. Or, because the hose is shrinking, it could pull the end connection out, both being, of course, very, very bad failures and dangerous failures. So a shallow braid can be very dangerous. Likewise, a steep or too wide of a braid angle under pressure, this hose is going to do the opposite. The hose will crush the core tube. The braids will flatten out and crush the core tube, and the length will grow. Now, the length growing a lot of times isn't a concern, but crushing the core tube, of course, could collapse the core tube, and crushing the core tube can remove the crimp pressure. So if this is a crimped hose and you crush the core tube, you can lose the crimp pressure on the end connection, and the end connection could separate from the core tube, which again is a very, very dangerous failure. So braid angle we found to be an extremely important factor in a braid package, and we do a lot of testing at Swagelok to maintain what we call a neutral braid angle. Every hose, depending on the braid material and the braid wire count and the braid or the hose diameter, has a different neutral angle, and we test that very closely to make sure that we maintain that neutral angle so that our hoses do not grow or shrink. They maintain the braid maintains pressure on the hose without allowing it to grow or shrink, therefore keeping our 4-to-1 burst and everyone's safe. Okay? So we want to take a quick break here before I turn it over to Nick. We want another poll question here, and this one has to do with what type of support are you looking for when selecting a hose, essentially, in your hose supplier. So this could be technical support. It could have to do with things like helping routing and those types of things. Is it availability of components, different end connections? Is it pricing support? Is it evaluation of how your hoses are being used and maybe helping select the proper hose? Is it fabrication support, essentially making the correct hoses? Okay, and while you guys are answering that survey question, there's another question came in. With the physics of pressure differentials I described, during a 1,000 psi non-destructive nitrogen pressure test on stainless steel tubing, okay, will the pressure of the test fall from permeation? With stainless steel tubing, the permeation rates are so minute that you will not see any pressure decay. When we do permeation rates on Teflon core hoses, the pressure decay is a macro size test. So with that type of test, it takes us quite a while, hours, to see significant pressure decay in a Teflon core. With a stainless steel, again, permeating at 1/10,000th of a Teflon post-sintered core, it would take months to see any kind of pressure decay on a stainless steel tube. So really, pressure decay tests are done only on Teflon core. But again, with just to reiterate that point, I suppose, with 1,000 psi on the inside, you will, no matter what the material is, even with stainless, you will have a minute level of oxygen still permeating in. It'll just be on such a low level that it will be non-detectable. Okay, good question. Okay, so poll results, tech support, that's good, and end connections. All right, that's good data for us. Swagelok does a lot to try to improve our tech support and offer as many different options as we can for services for these things. So thank you again for filling out the survey. And it looks like we're good to move on, so I'm going to turn this over to Nick, who's our hose specialist for field engineering, and he's going to go through some things that he has seen in the field.
Thanks, Doug. All right. So as Doug said, my name is Nick Iverson. I'm a field engineer with Swagelok, and just to kind of give you a little background, what the field engineer does is work really closely with our customers, and I spend a lot of time out in the field. I spend a lot of time on site looking at applications and just trying to gain a better understanding of what customers are doing and how that affects the products and how to optimize the product usage and the systems. So with hose being one of my areas of specialty, I've also spent a lot of time on site specifically looking at hoses. And the idea with hoses is always to knowing that a hose is not going to be a permanent component in your system. You know that the lifespan of a hose really depends on how you use it, and hoses need to be on preventative maintenance schedules. So that being said, when I go on site, what I look for in the following slides is kind of think of this as like a checklist of things to look for when you're walking around looking at your hoses, trying to understand the current situation and looking for improvements in your system and ways to increase the lifespan of your hoses. So like I said, here's the things to look for. Is this I think this is a building slide. Am I correct here? Click on it. Okay. So this is a general list of things to look for. And if you kind of look through this list, you see the broken wires, covers, abrasion, corrosion, ovality. We'll get into that. But a lot of the stuff on here, it's things that you can see just by glancing at a hose. You could be able to see that any of these things are happening to your hose. And all of the things listed here are going to affect the performance of the hose. And by that I mean it's going to affect the minimum bend radius. So it's more likely to kink, and it's also going to decrease the pressure capabilities of the hose. So anything that you see on this list right here, it's going to lower your life expectancy of your hose. So as we start to kind of cover each one of these points here, I'll let you know what causes this kind of damage, and then potential ways that you can address this damage. So the first one here is the worn cover, broken wires. This is typically caused by excessive abrasion. It's easy to spot it, but to address it, you need to do some root cause analysis and just try to figure out what could be causing the excessive abrasion. Is it rubbing against another hose, or is the location of the hose a problem where things can be moving past it and rubbing up against it? So when you have this excessive abrasion and you start to damage the cover, the job of the cover is to provide some protection for the braid. Once that cover is gone and removed, you're no longer protecting the braiding the way that you'd intended to. One of the issues with that also is that it can wick up moisture, and moisture can get underneath the cover and start to cause damage to your braid. In the pharmaceutical industry, damaging the cover means that hose is going to be less cleanable. That's also a problem there. And of course, if you damage the cover itself, you're lowering the pressure handling capabilities and you're reducing the kink resistance. So you're lowering you're increasing your minimum bend radius. Ovality is basically ideally your hose is going to be perfectly round, but as you start to bend a hose, you get tension. You get tension on the outside, and you get compression on the inside, and those forces are battling hoop strength, and then eventually your hose is going to start to become more oval shaped. Ovality, as you walk around and look at your hoses, any hoses that look like they're a little bit squashed, that means they're getting very close to their minimum bend radius, and kinking is imminent. So look for these. So what is a kink? I kind of discussed it as when the outside of the hose is in tension and the inside's in compression, and when those forces overcome the hoop strength, the hose kinks. Kinking is very bad for a hose because, like Doug mentioned earlier, a hose is made up of many layers, and we can't see what all those layers look like. From the outside, you can usually see that a kink has happened. Whether the kink is happening right now or it has happened in the past, there's permanent deformation on the hose. What we can't see is what the inside layers of the hose look like. And those inside layers, if they're permanently deformed, you've definitely lowered the pressure handling capability of your hose. So anytime you see a kinked hose, it's definitely time to replace it. Some other issues with kinking hoses could be that if you do actually damage the braid and the braid wires are sticking out, that's definitely a safety hazard. If you're handling the hose and there's you can see there in that lower left picture, you wouldn't want to be running your hand along that hose or moving it around if you could fish hook, that braid into your hand right there. That's definitely a safety issue. But also on these other pictures, it shows what happens when a hose bursts at a kink. Stiffness or hardness, these are obvious ones. If you look at a hose, you can see this right here, and a lot of you maybe have seen something like this. Pretty typical for a rubber hose that's been exposed to the environment. UV will definitely continue to cure the materials in the hose and cause it to crack and dry. You could call it dry rot. Exposure to extreme temperatures and chemicals, that could also damage the hose. One thing that people don't realize is that ozone can actually damage rubber hoses. So if your hoses are being used near high voltage power supplies, you should be sensitive to the ozone damaging your hoses, and also high intensity lighting sources. So if hoses are stored in a warehouse setting and there's high powered lighting above them, those hoses should probably be covered so you're not reducing the lifespan of your hose before you even install it. Color blisters. So if this is kind of a no-brainer too. If your hose is changing color, something's chemically happening to your hose. Whether it's chemical or it could be corrosion. But anytime your hose looks different than when you installed it, and it's not just because it's dirty, but something's happening chemically or physically to the hose, it's time to take a look at the hose and possibly replace it. And then just some other general damage to hoses that I see is a crushed hose, run over by something. It's not uncommon to see a hose that's been run over by a forklift, especially these rubber covered Teflon hoses down here. I see this a lot. I saw a question came in, but did it get answered? I think it might have.
I don't think it did. It's does the addition of fiberglass on your hose help with kinking?
So any of the reinforcement layers are going to help the core tube. It's going to reduce the chance of kinking. So yes, a layer of fiberglass will definitely reduce the chance of kinking. There's also accessories that you can add to hoses, like in addition to the actual hose material itself. There's different types of there's different types of spring and in some cases armor that you can apply to the outside of the hose. The armor, we have a product, it's called Armor Guard. It actually reduces how far you can even bend a hose. So it looks like we're kind of rounding out our time here, we got one more poll question we'd like to have you guys all answer. So, do you have a preventative maintenance schedule for hose? A lot of times people, a lot of times the preventative maintenance schedule for hose is replace on failure. So I would say this preventative maintenance schedule is saying, is there a preventative maintenance schedule other than replace on failure? No. Okay. So I would suggest for anybody that doesn't have a preventative maintenance schedule to either do this yourself, get out there and take a look at a sample population of hose and see if you see any of that damage that we had listed or any of those conditions that we had listed, or contact somebody that would be considered a hose expert to help you take a look at the hoses and maybe get together with that person and roadmap on how to improve your hose population, increase your life cycle. So moving on from here, I'll turn it over back to Doug to summarize and wrap it up.
All right, thanks, Dick. Yeah, so basically just a quick review, and I know we're out of time, but most importantly here, proper hose selection is a something that needs to be done to increase your plant efficiency and, more importantly, of course, your plant safety. And we see it done incorrectly many, many times. There's obviously many factors that go into it. And we try to capture all those factors with the acronym STAMPed. So if there's part of that you're not looking at when selecting a hose, you should really consider all the aspects of the acronym STAMPed. And Swagelok, of course, has hose experts that would be willing to help out with any application that you have. Not all hoses are created equal. We've seen so many times that efficiencies and safeties and things are improved a great deal because of the correct hose being used in the correct application. And what we see are most commonly are different permeation rates. Customers disappointed with permeation. They're using the wrong hose with a gas application, or maybe they're using the wrong hose in a pressure impulse application. And of course, understanding the right braid package can greatly impact the quality of a hose. And so we do a lot of testing and really understand everything that goes into the right braid design for each of our hoses. And then most importantly, inspect the hoses. You're going to find many problems with hoses and potential near future problems as well. So again, these are things that are fairly easy to see if you train yourself to do it on a regular basis, and it's important for the safety of everyone in the plant. With that, I think I'd like to turn it over to any questions, and I also would like to, of course, thank everyone for joining us today. Hopefully it was worthwhile and everyone got something out of this.
Doug, it looks like there's somebody was asking
the CNG
about the
hose
CNG
answer.
hose
Is that the CNG hose answer? That question was what hose is recommended for high pressure CNG hose up to 3,600 psi. We would recommend our thermoplastic line. We have an NG hose that's rated to 5,000 psi that would work well. It's rated to 5,000 in all sizes, so I'm assuming this is either a quarter, 3/8, or half-inch size or so. So I think we sell a lot of 3/8 with that. But anyways, if you look at the Swagelok hose catalog, there's the thermoplastic lines that we have, and usually we sell a lot of NG or 8R if you look at the Swagelok offerings to that application.
So Doug, I'd like to add to that too that the NG series of hose has the static dissipative core.
That's right.
Which is it's something you're going to want for a CNG hose, and also it has a perforated cover. With the CNG hose, if you don't have a perforated cover, when you do have some permeation through the core material, if your core permeates at a higher rate than your cover, then you're going to start to see blisters under the cover. So for CNG, you'd want to have a perforated cover. So there's little tiny pinpricks along the cover, and So anything that permeates from the core will also be able to get out of that cover without blistering it.
Good point.
A couple more questions.
Okay. Any other questions that we can help answer? And as always, if things come up later, please feel free to, contact your Swagelok representative, and they can get us involved as needed, and we'd be happy to help with anything that comes up.
Doug and Nick, thank you very much. This is really great information on hoses, and really want to thank you for this informative presentation, and also thank our audience. I do want to remind everybody about the survey. It is at the bottom of the page. The icon is to the right of the LinkedIn icon. Please make sure you take the survey so that we can find out more about your hose needs. Also, there is links to the right where there is extensive information. A lot of it has been talked about today, and definitely if you want to refer to information for yourself, you'll find a lot of information in the library. And if you have any additional questions, feel free to email us at the email noted on the screen. Our next Engineer to Perform webinar will be in the fall, and we'll continue to bring you subject matter experts on fluid system components. Also, if you're in the Midland area, please join us for Brews and Tools on June 6th at the Midland Brewing Company from 3 to 7 p.m. And just a reminder that this entire presentation will be available on demand later today, and you will be emailed a link to save or share with your teams. So thank you, and have a great day.